We'll start in 1 minute.
I feel like ever since I bought it, we've had pretty good stuff. Which I'm sure they got to figure out, they got to put up there. Yeah, WPs. Depending on how it is, I'm sure it's deeper. There was like, there's a couple spots out on campus that are right there, and at my house. Like that. Not bad to be in the valley.
Today we'll be in section 5.3 on multiplying polynomials. But first, we will review adding and subtracting polynomials. So like terms may be combined by adding and subtracting. Two terms are like terms if they have the exact same variable parts. So that means the same variables with the same exponents. So this is a brief review of combining like terms by adding and subtracting. This first one, 7x to the second plus 5x to the second. The variable parts are exactly the same. So we can combine them by adding, and we get a total of 12x to the second. So notice that the variable and the exponent do not change when you add them together, but the coefficients, the coefficient of the sum, 12, is the sum of the coefficients of the individual terms. Okay, the next one, 4y to the third plus 6y to the third. These are like terms, and we're adding. So we get a total of 10y to the third. The next one, negative 12w plus 18w. We get a total of positive 6w. This one, 7x to the second y minus negative 12x to the second y. We can rewrite this as 7x to the second y plus 12x to the second y. The variable parts are exactly the same. So we can add the terms, and we get a total of 19x to the second y. Okay, the next one, we have negative 3m plus 9m plus 15yr to the second minus negative 8yr to the second. Well, in the first step, we can go ahead and add the negative 3m to 9m. Those are like terms, so we get a total of positive 6m. And then for the other terms, we'll write plus 15yr to the second and plus 8yr to the second. And then the last step, since the second and third terms are like terms, we can combine them by adding. So our final result is 6m plus 23 times y times r to the second. And that is as far as we can go on that one. Okay, I'll let you simplify this next one. 2a to the second plus b to the second minus 6a to the second plus x to the second y minus 3x plus 7xy to the second. So simplify by combining like terms when adding and subtracting. So I'll give you 15 or 20 seconds to simplify that. Okay, what did you come up with? Altogether, there are 6 terms that are either added or subtracted. But there's only one pair of like terms, the 2a to the second minus 6a to the second. So 2a to the second minus 6a to the second is negative 4a to the second. For like terms, we perform the operation on the coefficients to find the coefficient of the result. Okay, there's one term with b to the second, so we still have plus b to the second. And what else? The next term here up here is plus x to the second y. Does it have, is there another term that is a like term with that one? So those are not like terms. So we have to leave plus x to the second y and then minus 3x. There's no other term that's a like term with minus 3x. We have minus 3x. And then plus 7xy to the second. That is as far as we can go to simplify that. So we're done with that one. Okay, so sometimes this, when you have the same variables but with different exponents, sometimes people will mistakenly combine them, but you have to make sure that the exponents are the same. If they are not the same, they are not like terms. Okay, now we can start multiplying polynomials. We'll start with some examples where we multiply monomials. A monomial is just a term, one term, mono meaning one. So on this one, 6y to the second times negative 3y to the fourth. Well, we can do it all at once, or we can do it in a couple of steps. We're just multiplying 4 factors, 6 times y to the second times negative 3 times y to the fourth. If you want, you can rearrange the factors. 6 times negative 3 times y to the seventh times y to the fourth. And we multiply the constants, 6 times negative 3 to get negative 18. And then we're multiplying that by y to the seventh times y to the fourth. And now we can apply one of those properties of exponents. And we get negative 18 times y to the 11th. Here we're adding the exponents, 7 plus 4. Okay, the next one, 5/8 x to the third y times 24 x to the fifth y. If it helps, you can rearrange the factors. So there are 6 factors. 5/8 times x to the third times y times 24 times x to the fifth times y. So if we rearrange the factors, we have 5/8 times 24 times x to the third times x to the fifth times y times y. And then 5/8 times 24, well, remember when you're multiplying fractions, you can look for common factors from denominators and numerators that cancel each other out. 8 goes into 8 once, and into 24 3 times, so we have 5/1 times 3/1, which is 15. And then times x to the third times x to the fifth, we add the exponents, so we get x to the 8th. And then y times y, that's y to the first times y to the first, so we get y to the second. Okay, the next one, we're multiplying 2/3 x to the second y times 3/4 x y to the second. Okay, rearrange the factors, so we can write this as 2/3 times 3/4 times x to the second times x times y to the second. 2/3 times 3/4 is 1/2. X to the second times x to the second times x is x to the third, and y times y to the second is y to the third. So that's as far as we can simplify that one. Okay, remember the distributive property of multiplication over addition, or sometimes we refer to it as the distributive property of multiplication over subtraction. So in general, even when we're subtracting, it can still be referred to as multiplication over addition, because subtraction is formally defined in terms of addition. Okay, so here's how the property is stated. Let a, b, and c be real numbers. Then a times the quantity b plus c is equal to a times b plus a times c. So you can see why it's called the distributive property of multiplication over addition. This means a times the quantity b plus c, so we distribute multiplication over addition. And then, analogously, if we have a times the quantity b minus c, then when we distribute multiplication over subtraction, we get a times b minus a times c. Okay, let's move on to the next page. Now we're multiplying polynomials again, but this time we're not just multiplying monomials. In this first example, we're multiplying a monomial and a trinomial. So inside the parentheses, we have a trinomial. It's called a trinomial because it has 3 terms in it. Okay, so we distribute multiplication by 8x over addition and subtraction. So I'll write this in a little bit more detail than is absolutely necessary to start with. We multiply 8x times x to the second, so 8x times x to the second, and then plus 8x times 2x, 8x times 2x, and then minus 8x times 15. And 8x times x to the second, that's 8x to the third, because x times x to the second is x to the third. And then 8x, we're adding 8x times 2x. And this one is 16x to the second, because 8 times 2 is 16, and x times x is x to the second. And then minus 8x times 15, this is minus 120x. So 8 times 15 is 120, and then one variable of x. And that is as far as we can go. We can't add and subtract further because the terms are not like terms. In the next example, this time we have negative 9r to the third t times the quantity r to the second minus 3rt plus 5t to the second. Okay, so we're going to distribute multiplication over subtraction and addition. So first multiply negative 9r to the third t times r to the second. And then negative 9r to the third t, you can think of that as a negative times a negative. And a negative times a negative is a positive, so I'll write plus 9r to the third t times 3rt. And then finally, we have a negative times a positive, so that translates to subtraction. So I'm going to write minus 9r to the third t times 5t to the second. So as usual, you always have to be careful with the signs, the positives and the negatives. Okay, on the term on the left, negative 9r to the third t times r to the second is negative 9r to the fifth times t. And that's because r to the third times r to the second is r to the 3 plus 2, or r to the fifth. Okay, then the next term, first we multiply the constant factors. 3 times 9 is 27. R to the third times r to the first is r to the fourth. And t times t is t to the second. And then finally, we're going to subtract 9r to the third t times 5t to the second. First multiply 9 times 5, which is 45. So minus 45 times r to the third times t to the third, because t times t to the second is t to the third. Hey, that's as far as we can go on this one. In the next three examples, we're multiplying binomials. So a binomial has two terms in it. So the quantity x plus 3y is a binomial, and we're multiplying it by another binomial, x minus 2y. Okay, so we're going to apply a type of distributive property, and there's more than one way to show you how to do it. Hey, but what I'm going to do, I'm going to show you, pick one of the terms in one of the binomials, so we're starting with x, and I'm going to multiply x times each of the terms in the other binomial one at a time. So x times x is what I do first. So x times x, I get x to the second. And then I'm going to subtract x times 2y. So minus 2yx or 2xy. Okay, so what I did was I distributed multiplication over the x minus 2y by multiplying each of those terms by x. Okay, then the other part, now we're going to distribute multiplication over x minus 2y by positive 3y. So then we get 3y times y. I'll write it as plus 3xy. You can write it as 3yx, but I'm writing it plus 3xy. And then we have to multiply 3y by the other term in the other binomials. So we can write minus 3y times 2y. So I'll go ahead and write it in a little bit of detail, minus 3y times 2y. And then we simplify further. So there's only one term with x to the second. Notice that in this case, the two middle terms are like terms. They have the exact same variable parts, same variables and same exponents. So minus 2xy plus 3xy is 1xy, positive 1xy. So we just write plus xy. And then finally, minus 3y times 2y is minus 6y to the second. Hey, this is as far as we can go on that one. Okay, the next one, we're multiplying two binomials again, 2m plus 7n times m plus 7n. Hey, take 30 seconds, multiply that out, see what you get, and then we'll compare notes in about a half a minute. And since we are multiplying one binomial by another, we have to multiply each of the terms in one of the binomials by each of the terms in the other binomial. So we could start by multiplying 2m times m, 2m times m, and then we can add 2m times 7n, I mean, so plus 2m times 7n. Then we shift over and multiply the positive 7n, that is, times m plus 7n. So 7n times m, I'll write that as plus 7n times m, and then plus 7n times 7n, plus 7n times 7n. 2 times m is 2 times m to the second. And then the next term, 2m times 7n, 2 times 7 is 14. And then 14 times m times n. And then the next term, 7n times m, I'm going to write it as 7 times m times n. And then finally, 7n times 7n. 7 times 7 is 49. And n times n is n to the second. Notice that the two middle terms, the second term and the third term, are like terms. So we can combine them by adding. And so our simplified product is 2m to the second plus 21mn plus 49n to the second. That's as far as we can go on that multiplication. Okay, the next example, we're multiplying two binomials again. The binomial c plus 8d, we are multiplying that by another binomial, c minus 5d. Okay, so start with c in the left binomial, multiply c times each of the terms in the other binomial. So c times c is c to the second, and then minus c times 5d, I'm going to write it as minus 5 times cd. Then we shift over to the plus 8d. We're going to multiply 8d times c minus 5d. So first, 8d times c, I'll write it as plus 8cd. And then minus 8d times 5d is minus 40d to the second. The two middle terms are like terms that can be combined by subtracting and adding. So our final result is c to the second plus 3 times cd minus 40d to the second. In the next example, we're multiplying a binomial and a trinomial. So the concept is the same. We'll begin with the x in the binomial. We're going to multiply x times each of the three terms in the trinomial. Then after that, we're going to subtract 7 times each of the terms in the trinomial. And then if there are like terms, we'll combine the like terms. Okay, so first start with x. Multiply x times 5x to the second. We get 5x to the third. And then we're going to add x times x, which is plus x to the second. Then we're going to subtract x times 5, which is the same as minus 5x. Okay, then shift to the next term in the binomial. X minus 7 is equivalent to x plus negative 7. So we're going to, in effect, multiply negative 7 times each of the terms in the trinomial. Okay? Or you could think of it as subtracting 7 times 5x to the second, we get the same result. So if I subtract 7 times 5x to the second, I'm subtracting 35x to the second. And then I'm going to subtract 7 times x, so minus 7x. And then we're going to subtract 7 times negative 35. But if you subtract negative 35, that's equivalent to adding 35. Another way to think about this is think of multiplying negative 7 times negative 5, which is positive 35, so we're going to add 35. Okay, then we combine like terms. There's only one x to the third term, so we have 5x to the third. There are two terms with x to the second, plus x to the second minus 35x to the second. Those combine to give us minus 34x to the second. And then minus 5x minus 7x, the total there is minus 12x, and then plus 35. And that is as far as we can simplify that one. Okay, we have another example where we multiply a binomial times a trinomial. Okay, so start with 6e, multiply 6e times each of the terms in the trinomial. Okay, so 6e times 3e to the second is 18e to the third. And then plus 6e times 2e is plus 12e to the second. And then minus 6e times 7 is minus 42e. And then, in effect, just multiply negative 1 times each of the terms in the trinomial. So we're going to have minus 3e to the second. So what we can do is we can put the terms in columns with terms that are like terms. So minus 3e to the second, I'll put that below the 12e to the second. So we have minus 3e to the second. And then minus 1 times 2e is minus 2e. And then negative 1 times negative 7 is positive 7. And then we combine like terms, the final result, 18e to the third and 12e to the second minus 3e to the second is positive 9e to the second. And minus 42e minus 2e is minus 44e, and then plus 7. Okay, the next example is just multiplying two binomials. So first we multiply x times each of the terms in the binomial x plus 3y. And then we'll multiply negative 3y times each of the terms in x plus 3y. So first, x times x is x to the second. And then plus x times 3y is plus 3xy. And then minus 3y times x is minus 3xy. And then minus 3y times 3y is minus 9y to the second. The two middle terms are like terms, and those combine to give us 0. So we have x squared plus 0 minus 9y to the second, so we'll just write x squared minus 9y to the second. Okay, so the two like terms in the middle added up to be 0. So another observation is the two binomials that we multiplied are called conjugate binomials. The only difference is one has subtraction and the other one has addition. Each of those has x and each of those has 3y. So this will occur in general if you multiply conjugate binomials. Okay, the next page. Here we're multiplying two binomials. One binomial is 6b minus 3/4 mw, and the other binomial is 6b plus 3/4 mw. So note, these are conjugate binomials. But let's go ahead and multiply it all out. First, multiply 6b times 6b. We get 36b to the second. And then we're going to add 6b times 3/4 mw. We'll do this in a couple of steps. I'll write it as 6 times 3/4 times v times mw. And then we multiply negative 3/4 mw times the binomial. So negative 3/4 mw times 6b. Let's write this as minus 3/4 times 6 times mwv. And then minus 3/4 mw times 3/4 mw. So I'll write this as minus 3/4 times 3/4. And m times m is m squared, and w times w is w squared. Okay, the first term, 36b to the second. Let's go ahead and simplify this. 6 times 3/4 dmw is 18 over 4, or plus 9/2. I'm going to rearrange the variable factors. vmw, I'm going to write it as plus 9/2 times mwb. And then minus 3/4 times 6 minus 18 over 4, or minus 9/2 times mwb. And then on the right, minus 3/4 times 3/4 times m squared w squared is minus 9/16 m squared w squared. And the two middle terms add up to 0 again, or combine to give us 0. So when we eliminate those, we're just left with 36v to the second minus 9/16 times m to the second w to the second. Okay, the next one, ax minus 3n times ax plus 3n. So what's going to happen this time? The,
Conjugate.
yeah, they are conjugates again. So if we multiply it all out and we get 4 terms, the 2 middle terms will combine to give us 0. Yeah, so these are conjugate binomials. So the same pattern that we've seen in the previous 2 examples will occur again. But let's go ahead and multiply it out. Ax times ax is a to the second x to the second. And then plus ax times 3n. We can write it as plus 3n times ax. Okay, then we shift over and we multiply negative 3n times ax. So this is minus 3n times ax. And then negative 3n times 3n is negative 9n to the second. Because a negative times a positive is a negative. And the 2 middle terms are like terms that combine to give us 0. So our simplified answer is a to the second x to the second minus 9n to the second. Okay, the next example, what does this mean? The binomial x plus 4/7 to the second power. So what do we do on this one? Well, on this one, inside the parentheses, we're adding 2 terms, and we're squaring the binomial. Well, when you square something, it means to multiply that something by itself. So we can write this as x plus 4/7 times x plus 4/7. And then we just multiply the 2 binomials. First, x times x is x to the second. And then multiply x times 4/7. So we write plus 4/7 x. And then the next step, we multiply 4/7 times the binomial x plus 4/7. So 4/7 times x is positive 4/7 x, so we write plus 4/7 x. And then we multiply 4/7 times 4/7. So we're adding 4/7 times 4/7. And so we add 16/49. Hey, can we do any more on this one? The 2 middle terms, or the second and third terms, are like terms, so they can be combined by adding. So our simplified result is x to the second plus 8/7 x plus 16/49. This result, this trinomial, is an example of what is called a perfect square trinomial. So from now on, you're going to see this expression, perfect square trinomial, repeatedly from now until the end of the semester. And briefly, a perfect square trinomial is the trinomial that you get whenever you square a binomial. So anytime you square a binomial, expand it and simplify it, the result will be a perfect square trinomial. Okay, in the next example, we're multiplying, or we have the binomial 9a minus 4b to the second power. So the result is going to be a perfect square trinomial because we're squaring a binomial. What does it mean to square something? It means to multiply that something by itself. So when we square the binomial 9a minus 4b, we multiply 9a minus 4b times 9a minus 4b. Okay, I got an answer online. To square something means to multiply that something by itself. Okay, then 9a times 9a is 81a to the second. Then we're going to subtract 9a times 4b. So we subtract 36 times ab. And then the next stage of the multiplication, we are going to multiply negative 4b times the binomial 9a minus 4b. So negative 4b times 9a, that means we're going to subtract 36ab again. And then finally, negative 4b times negative 4b. A negative times a negative is a positive, so we're going to get plus 16b to the second. Okay, let's make another observation about squaring a binomial. In the previous example, when we squared the binomial x plus 4/7, the second and third terms are identical, plus 4/7x plus 4/7x. Well, the same thing occurs down here. This time we're squaring the binomial 9a minus 4b. The two middle terms, or the second term and the third term, are identical, minus 36ab minus 36ab. So that is always going to happen whenever you square a binomial. And the second and third terms are like terms, so we can simplify further. We get 81a to the second minus 72ab plus 16b to the second. Okay, the next example, we're squaring a binomial, so we have 3n to the second minus 5y times 3n to the second minus 5y. Okay, 3n to the second times 3n to the second is 9n to the fourth. And then minus 3n to the second times 5y is minus 15n to the second y. Then we shift over minus or negative 5y times 3n to the second. We can write that as minus 15n to the second y. And then finally, negative 5y times negative 5y is positive 25y to the second. The second and third terms are identical. They are like terms, so we can combine by subtracting. And we get 9n to the fourth minus 30n to the second y plus 25y to the second. Okay, one more example. We have a few seconds left. So we can, well, we ran out of time, but this just means 9x plus 8y times 9x plus 8y. I'll leave the rest of that for you to do. You saw the previous examples, so. Okay, time's up. Go ahead and sign in for attendance.
Good one. Have a good day.
Dude.